to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So I do want to start this episode off before we get too far that if you are celebrating Easter this weekend, happy Easter to you, and hopefully you're spending some time with your family. But aside from that, today is a very good day because we get to talk about one of the best combinations to ever grace this world, that being Homelabbing and software development. Now, as someone, as you all well know, if you've listened to the podcast for long enough, I am someone who both has a home lab and is also working on a video game side project in my free time, and to be honest, my home lab has played quite the critical role in the development of my video game, both in terms of things like version control, automation, as well as like different things like build, test, and development environments, to be quite honest. Basically everything that kind of goes into the whole software development lifecycle, my home lab has basically played a role in through this development. So that's kind of what I wanted to touch on today, and basically kind of go over how you can use your home lab to accelerate your video game development. Now, while this episode is going to be kind of more tailored towards video game development, it is by no means exclusive to video game development. You can absolutely take these same principles and apply them to any other software development project you're working on, whether that's some kind of server application or that's just some other generic desktop application. You know, whatever the case is, you can absolutely do it. So that is what we're going to get into today. But before we do that, let's start off with our trivia question. So Apple announced back in June of 2013 at WWDC CarPlay for the very first time, and it would be available on all iPhone 5 and later models running iOS 7.1 or later. In September 2014, the first car with a full version of CarPlay was released. What was that car? So what was the car with the first full version of Apple's CarPlay that was released in September of 2014? And I'll give points for both the manufacturer and the specific model. And that is your trivia question for the week. Now, hearkening back to last week's episode, even though we aren't talking about cars in this episode, it's nice to find a way to weasel my way into talking about cars, even if it's only in the form of a trivia question. But with that, let's get into this week's cybersecurity tip. Now, this week's cybersecurity tip is to stay informed about the latest cybersecurity threats and vulnerabilities. Now, I like to think that this podcast does at least a fairly decent job of keeping people up to date about, kind of what's going on in the cybersecurity world. But obviously, there's a couple issues with this podcast. One, it's only weekly. So if something happens on, say, a Monday, assuming it's big enough for me to, talk about, that's one thing. You're not going to hear about it for basically a week. And the other thing too is, of course, I'm just one guy. I have a limited amount of resources, a limited amount of time, so I can only do so much research, and there's a lot of other stuff that I like to talk about. But it goes further than that too, because whenever it comes to anything information related, whether that's general news or whatever, it's always best to get your information from a variety of sources, because there's this thing in the world called bias. So sometimes, people will try to downplay or kind of overemphasize things that they really shouldn't be. So it's always good, to get multiple angles from things. So first you have to kind of find reputable sources, but the reason why you also want to do this, as we'll kind of get into later, is because the more up to date you are on this stuff, the better you can both protect yourself, as well as make sure your various software applications and tools are up to date as well. But when it comes to sources, of course you want to be looking for reputable sources. Of course you want to be looking for a source that has some sort of background in cybersecurity, whether that's an organization like CISA or the Cybersecurity and Information Security Agency, or NIST, the National Institute of Standards and Technology, things like that, cybersecurity kind of focused organizations, or various cybersecurity types of blogs. Those are also good sources as well. What you kind of don't want to do is just see a random post on like social media or something from an account you've never heard of before. Definitely probably want to take that with a grain of salt. Now, I guess there is a chance that whoever posted that might actually have a background in cybersecurity, but for me, at least personally, whenever I find anything when I'm browsing the black hole that is social media, which granted I don't really do much these days because how horrible it is, but the off chance that I do come across something that I find peculiar, interesting, or otherwise, piques my interest, I generally do a search on my own for whatever they're talking about, just because I'm not sure the best way to put this, but I think most people that have been on social media within the past few years know how terrible it is in terms of like the actual content that gets posted on those kinds of platforms. But that's neither here nor there. So that's the first thing you want to do, is you want to look for reputable sources. So a couple ways that you can do that is you can either subscribe to like newsletters or podcasts like this one, and just kind of read up on the latest security, because one thing that will be, I guess it kind of depends on how you consume your news and whatnot. If you are someone that likes to read like newsletters, for instance, then maybe subscribing to newsletters would be good for you. Because one kind of issue is if it's something that you just kind of say like, I want to do this, but you don't have any kind of reminders in place to remind you to go do that, your likelihood of actually remembering to do it is probably not as high. So that's why things like subscribing to podcasts or newsletters or things like that would be a pretty easy way to kind of have those regular notifications coming in, that, hey, here's some new security news, that kind of a thing. Another thing you could do too is like, if you're interested in kind of engaging in kind of like the online forum type worlds, there's plenty of like different forums out there and communities like specifically focused around like cybersecurity. So if you want to kind of get involved in those, that's also a way. And but when I say get involved, I don't mean you have to be going on there and like posting questions and answers and like talking with people. You can be what they call a lurker. You basically just go there just to kind of see what other people are talking about. Another one is to kind of attend various cybersecurity conferences. So these are things kind of like DEF CON, Black Hat, RSA conference, things like this that are kind of focused specifically around like cybersecurity. Now, things like DEF CON, you're probably not necessarily going to get up to date on like the latest cybersecurity news. But one thing that's pretty cool about DEF CON is they have a lot of, kind of like hands-on type things where someone will like do like live demos of like how they like exploit things, which can be pretty cool to see. So that's kind of like sources and how you can kind of like get informed on stuff. The other thing you also want to be aware of too is vulnerabilities, right? Vulnerability alerts, because this is where it really hits you and your services, because you could have, the best spidey senses when it comes to phishing emails. But if you're running some outdated server with vulnerable software and someone hacks you, well, you're kind of out of luck. So staying up to date on the latest vulnerabilities, specifically for the tools and software you're running, is key, because there are so many vulnerabilities that come out these days that it's quite honestly hard to stay up to date on all of them. So if you can at least keep track of the ones that affect the applications that you use on a daily basis, especially anything that you have that's public facing or that the public internet can see and potentially have access to. Those are the very core things that you want to make sure that you have up to date. For instance, let's give a horrible example. Let's say you have a public facing SSH server. You definitely want to make sure that that SSH server is up to date, because if there is, say, a 0-day in SSH, that's basically just a sitting duck at that point. Now, I say that's a bad example because, let's be honest, you shouldn't have SSH publicly exposed to the internet. Now, if you have something in the cloud, it's, I guess, maybe a little more understandable, but with how you, I guess it personally, it depends on how you have your cloud environment set up. If you only have one service, like only one server running in the cloud, that's one thing. But if you have like a suite of servers, you should probably have some kind of firewall like in the cloud specifically for it, that you basically kind of make it its own isolated network. So then if you do need to get in and like manage any of those servers through SSH, you have like some kind of VPN tunnel to get you in there. Or you could, I guess, just manage it all from like the console, since I'm pretty sure most cloud providers, if you do anything like a virtual machine type instance, they'll have some kind of way where you can access like the shell of the system like through the web console. So that's also another thing you could do. But I guess we're kind of getting off a little off topic here. But when it comes to vulnerability alerts, you can set up sources from things like the National Vulnerability Database, things like that. There's also like also checking on like CVEs for monitoring CVEs for any kind of applications you have. That's another way you can do it. Monitoring things like security blogs. There's one like the Curbs on Security is, I think, a pretty good one that's kind of out there. Hacker News is another one. So there's a lot of things out there. Another thing you can also keep an eye out for is like bug bounty type stuff too. So typically companies will put out what they call bug bounties, and they kind of vary. Actually, I think we talked about one not too long ago. Actually, it was probably a while ago, when Apple came out with their whole. We all know how spectacular the Apple Intelligence rollout has gone, of course. But when they released their like secure cloud Apple Intelligence environment thing, they put out some pretty hefty bug bounties. If anyone could find like a way that you could get some kind of I forget all the details, but like basically there was like bug bounties out there. Like if you could find a way to like get access to like data that you weren't supposed to get access to, they could, I forget what the max sum was, but it was like hundreds of thousands of dollars. Like it was a lot of money. So that's one thing that companies will do, is they'll basically put bug bounties out there to encourage people, if they find vulnerabilities in their software, to disclose it to the company rather than selling it, on the dark web, for instance, and making money that way. And then just kind of general, security awareness things. If your company that you work for has some kind of like cybersecurity training, first of all, they probably make you take that anyway. But just kind of like, making sure you're aware of, what's going on, and maybe taking like training or courses somewhere. I mean, there's plenty of good like YouTube videos out there as well if you don't feel like subscribing for like online courses, which I don't blame you. So there's a lot of ways that you can do that. So the reason why, again, this is so important is being informed, just of general cybersecurity principles can help you identify potential attack vectors. Like one thing we've talked about so frequently on the podcast, especially in the cybersecurity tip, is various phishing related attacks. So being up to date, and kind of understanding, what the latest phishing attacks are will help you to more easily identify potential phishing attacks if they come your way, and obviously avoid them. But also too, like just kind of general, what are, threat actors trying to do to gain access to things? What's the latest malware that they're using to, be able to identify it. What kind of, because I mean, malware is evolving like crazy. Like there's like back in the day, if you got ransomware, basically as soon as the ransomware got on your system, it would basically take it over. But nowadays, it's gotten to the point where some ransomware will literally just kind of sit around for a while and kind of check to even see if you're a good target, or maybe even see if it can't laterally move to a more juicy target. And it's not just like ransomware either. Like there's other malware out there that will literally just kind of, once they infect your system, kind of just lie dormant for a while. Until they either get a message from like their command and control system, or maybe they just have a set time period to kind of wait. And there's a couple reasons why this isn't necessarily a bad idea, because if you go to a sketchy website and you immediately have issues with your computer, it's pretty easy to see, where that came from. But for instance, let's say you went to a sketchy website and everything's fine and everything continues to be fine for, a few weeks, maybe even a few months. And then slowly, after a while, like you kind of start noticing your computer starts slowing down. That's a lot less noticeable that, hey, I probably have malware, than, oh, I went to this sketchy site and now my computer runs like garbage. So that's kind of one thing. And of course, there's tons of different strategies that malware authors are using these days, and we could probably sit here all day talking about it if we wanted to. But again, making sure you're up to date on things like the latest vulnerabilities is a big one, because in order for threat actors to get malware on your system, they have to exploit some sort of vulnerability, whether that's a vulnerability in software somewhere that they can get, maybe some kind of remote code execution, or maybe they like I'm not sure if you heard about the whole 4chan incident. We're not going to like go super into it, but my understanding of what happened was someone uploaded like a maliciously formed quote unquote PDF file, which basically let them kind of hack the system essentially. So something like that, maybe, like a malformed file that you say it's something, but it's really something else, which is not very uncommon. I'm not sure about you, but I have heard plenty of stories, and I may or may not. I cannot confirm nor deny that I have participated in this. But basically, renaming a file to a different extension in order to bypass some kind of filter somewhere. That is a very common thing. So of course that's kind of like the general crux of malware. But again, in order to get that to you, there has to be some sort of delivery mechanism, technically some sort of vulnerability, again, whether that's software or maybe it's in the human psyche and they get you through some kind of phishing email and exploit the vulnerabilities that are programmed into our brains. Make sure you stay up to date on various, general security knowledge, what's the latest in all these various attacks as well as vulnerabilities, so you can keep your systems and your knowledge up to date. And that is your cybersecurity tip for the week. So moving right along, let's get into what nerdy stuff have I been up to this week. So after long last, we are back to talking about some video game updates. You might have been able to guess that with a little bit of, I don't know if I was necessarily foreshadowing it, but if you looked at the title of the episode, you might have been able to gather that we were talking about this. We're finally back to doing some video game programming, which I guess big asterisk on that, because we really didn't do much video game programming, but we did do a lot of, I guess, Homelabbing related video game programming stuff. But anyway, to demonstrate how long it's been since I touched my video game, my first task was to update the graphics library I'm using to Raylib 5.5. Now, if you're not familiar with the premise of what my video game is, because One, you might be new, and also I haven't talked about it in a few months, so I don't blame you if you forgot. The video game that I am working on is a from-scratch C++ implementation of basically recreating Pokemon from scratch with C++. And my original plan from the get-go was to also do my own graphics library. I quickly realized that was kind of a pipe dream because making my own graphics library would have been just as big of, if not a bigger project than actually the video game itself. So I decided that I would use a library for it. But everything else has been developed from scratch by me. But I think it's also worth noting that while I am saying I'm updating to Raylib 5.5 and I'm coming from Raylib 5.0, Raylib does a really interesting updating scheme. They don't iterate, how do I say this? They don't go from, say, 5.0 to 5.1 to 5.2. They'll sometimes just randomly skip like a bunch of numbers. So in this case, they literally just skipped from 5.0 to 5.5. Not sure why, but that's what they decided to do. And for context, this update came out in November of 2024, and it is now April of 2025. So it has been a while. Now, granted, it hasn't been since November of 2024 that I last touched my video game. I just never got around to updating the graphics library. It was something on my to-do list for sure, but it was, kind of taking a back burner because I was working on other things. Also, kind of as a quick aside note, if you go to the releases page for Raylib 5.5, if you scroll down a ways, you might find a familiar name on there in the contributors list, just saying. But looking at my Git logs, the last update I actually made to the video game was in the middle of January of this year, so basically 3 months ago, which is kind of a big yikes. But if you'd be thinking that this would be a snooze fest of an update, oh, you just updated the graphics library, what'd you do? Just change a number in your make file and ran it and everything was good? Well, yes, but actually no. So you're correct in that's literally all I had to do was in my makefile just change the Raylib version number from 5.0 to 5.5 and update it, which was super easy to do. I already had all the code and everything implemented to do that update. But when I updated, things broke, which is why you test things. Specifically, the thing that broke when I updated to Raylib 5.5 was the draw rectangle rounded lines function that I was using. So I'm not sure. Now, technically speaking, if we wanted to critique Raylib here, this would essentially violate the versioning scheme that they were using, because technically, whenever you if you go by the semantic versioning, the major release version is technically supposed to be reserved for API breaking changes. In other words, you changed a function, so if you update to this version, you're gonna probably have to rework some of your code potentially. Whereas the minor version, which is that second number, is basically, yeah, this is an update, but there's basically no changes to the API, so you're basically good. And then the third number is a bug fix, so we noticed there was an issue in one of our functions. It wasn't outputting what it was supposed to, for example, so we updated it. So technically speaking, because this function changed between versions, it technically, I guess, should have been a 6.0 update, but that's neither here nor there. Again, semantic versioning, it's, as they say in Pirates of the Caribbean when it comes to the pirate code, they're more like guidelines anyway. But anyway, so that was the big update, which in fairness, it was a very trivial fix, because they added a additional function called draw rectangle rounded lines EX for extended, which was basically the exact same calling convention that I was already using. So I basically just had to do a bulk rename of every case where there is draw rectangle rounded lines to EX at the end, essentially. So that was a pretty easy and trivial fix to do. Um, but that wasn't the only issue that I ran into. I also hit another issue, which happened in one of the auto-generated files that get created during my build process. So my build process has two different variants. So the first variant is just a standard build. It just compiles all the C++ and C files and creates the binary, and then basically looks in the file system for the assets. So things like the fonts, the images, all that good stuff. But there's a second version of the build system, which allows you to embed all of the assets into the executable itself. So Raylib has a couple of very handy functions that allow you to do this. It'll basically take, image files, font files, I think even like audio and video files too, and basically convert them into .h files, like header files that you can then include into your project and compile them into your binary. So that's another version I have. I still haven't, which I really should. I haven't fully settled on which one I want to do for the final release, which granted, we're still a long way away from that, so I still have plenty of time to think about it. But personally, most of the builds that I've done have been kind of the embedded version. But during the embedded version, specifically with the I think it was the it was the font. For whatever reason, they included this new is GPU ready variable, which wasn't defined anywhere. The only instances of this being defined were in like .c files. So like rtext.c, for instance, was one of the files that it was defined in, and it was defined via extern, but it was never like defined in like a header file, which was rather strange. So this took a little bit of kind of searching and debugging to try to figure out a solution. But my solution basically ended up being that in one of my files, I basically, in the kind of like the if-def check, like if I am embedding assets, basically before I include the font file, to basically just extern this is GPU ready variable, and that made everything happy and it worked like it was supposed to. So that was kind of a very interesting bug that I had to fix, but it's working now. And then, so that was the code changes that I got to this week. Again, basically nothing. It was basically just making it in compliance with the latest Raylib graphics library version. So nothing really all that interesting, but definitely very important updates to be made nonetheless. But that's not where the fun ends. Oh, no. Because when it came to me actually pushing these changes, things kind of fell apart because for whatever reason, I don't know if it's because I hadn't touched the CI/CD pipeline in 3 months. Again, CI/CD, for those that don't remember or don't know what it means, it's continuous integration, continuous development, deployment, however you want to say it. Basically, you push a change to your remote repository, which then kicks off a pipeline, which then does a bunch of different things. Typically, it'll do things like build your code, test your code, and then do any kind of deployment that's needed to get it out to production. And literally all you had to do was do like a git push, and everything else from the deployment aspect is basically handled for you. So it makes your life so much easier. But for whatever reason, my GitLab runner that I used for my CI/CD pipeline would not pick up the job. I don't know why. I didn't have this issue before. But my guess is it had something to do with the deprecation that GitLab pushed in one of their updates at some point, which basically took away project level registration tokens. So essentially how GitLab works with runners is previously you could register a runner specifically for a project that you had. And then so those were like specific project runners, and then they had like instance runners as well. So instance runners would basically be you created a runner that kind of existed within your self-hosted GitLab instance. You could also link these to gitlab.com as well. But they would be specifically for your GitLab instance. So whenever any CI/CD pipeline job wanted to kick off, that runner could basically go to any single project. It wasn't specifically tied to a given project. Anyway, at some point, GitLab decided that they were going to do away with these project-specific runners. And I'm assuming that's probably what my issue was, because I'm pretty sure this runner was a specific project runner. It wasn't like an instance runner. So anyway, I kind of got around to messing around, trying to play with things, because the thing that was weird about it was the runner was still detected as online by GitLab, but it wasn't getting any jobs assigned to it. So yeah, like I said, I wasn't exactly sure why it was doing this, but as the Brits would say, I did some farting around, and eventually I did get it working. Basically, what I ended up doing was essentially kind of removing the old config.toml file, because it was kind of like causing some issues, and kind of like regenerating it. And then once I did that and, kind of created it as an instance runner rather than a project runner, and just tried to rerun the pipeline, then everything started working, and it started building my documentation, my image as well. But if you thought everything was all fine and dandy, you would be sorely mistaken, because for whatever reason, Docker wasn't liking my GitLab self-signed cert for whatever reason. So whenever it would try to push my documentation container to my GitLab registry, it would just be like, oh, it's not a trusted, URL, not a trusted certificate. We're just gonna crash here. So that was not fun. Now at this time, I didn't remember having this problem before when I first set up the pipeline, and this is what we call in the business a little bit of foreshadowing. But after kind of like tweaking a bunch of different things and changing a bunch of different config options and settings and all kinds of stuff, I did eventually get the pipeline working, and it didn't have this certificate not valid error anymore. But because I changed and modified so much stuff, I wanted to root cause the problem, figure out what the actual solution was, so I know in the future which one of like the 5 or 6 things that I did actually was the one that fixed it, or was it maybe a combination of all the above. Turns out the new config that got generated when I created the GitLab runner recreated the runner in a slightly different manner, I guess. Like some of the options that it had were different from my previous config file. Because like when I compared the two together, I noticed there were like a few lines that were different between the two. But the real facepalm moment, and here's where the foreshadowing comes into play, when I was spinning up a separate GitLab runner, which we'll get into in a little bit, I rediscovered this. So while I was troubleshooting all this, the whole self-signed cert issue, the thing that really gave me the facepalm moment was so I have a project on my GitLab called I think it's called basic CI/CD pipeline or something, which was basically a demo project just for me to kind of get my hands dirty initially testing and playing with CI/CD pipelines in GitLab with my own GitLab runners before I kind of put it and implemented it into my video game. And literally in that README file, there is a specific section saying you need to make these changes to your config file, otherwise you'll run into self-signed cert issues. So, yeah, if I would have just, RTFM'd and read the freaking manual and actually looked at my documentation, all that time troubleshooting would not have happened. So yeah, that was an absolute facepalm moment. And like I said, the reason I rediscovered this was I later went to set up a different runner. So currently the runner that I had previously was an x86 Linux runner. So basically I could do Linux builds with x86 architecture, basically Intel and AMD CPUs. But the new runner that I set up was also a Linux system, but for ARM64. So I could basically do ARM builds for Linux systems. And as I was setting that up, I of course went through the documentation that I wrote for myself on how to, create a GitLab runner. And of course, plain as day, right there, it was this is how you avoid the self-signed cert error. So yeah, I should have read the documentation. But anyway, I do have. So that was the other runner that I set up. So now, and I also configured the pipeline to do simultaneous builds for both x86 and ARM, as well as tests for both of those. So the nice thing about that is the time that the pipeline takes to run is basically unchanged. It's still the same amount of time, but I basically build for both of the platforms, which is fantastic. And the end goal is to get both Windows and Mac OS runners doing builds and tests as well. So that way I can have builds and tests for all the operating systems and all the architectures that I plan to support to basically ensure that everything works. Because so many times I have, done a push, and it either didn't work on the Linux build, and then usually it's because I forgot to include something that Mac OS was inferred for me and did for me, but Linux is like, hey man, where is this? But other instances too, like sometimes I'll get like of course it's always a Windows error. Everything will be working fine, and then just one day I'll be like, just make sure that this works and builds on Windows, and then of course it doesn't, and then I'll be like, okay, what's the issue here? So then I spend some time debugging it, figure out what the issue is, implement the fix, and then it's kind of a whole deal. But the nice thing is, once I get runners set up for all the various operating systems and all the platforms, that'll basically go away because I'll be able to instantly know when something doesn't work for a specific platform because my pipeline will fail. So that is the plan. I mean, I already do have a Windows dev environment for x86, and I have one for ARM as well. And then I have a Mac OS for ARM environment as well as a Mac OS for x86 environment. So it's basically just a matter of me setting up the runners for them. But yeah, that was kind of the big thing. But that we're still not done, because once I got that extra runner added in, I decided that I wanted to work on adding static application security testing, or SAST testing, which I guess that's actually redundant, into my pipeline. So the first option that I went with was the free gimme that was included with GitLab, and this is called semgrep. And I was a little unsure about the results at first, because when I first ran it, it said everything passed, and it spit out like a couple warnings for like syntax related things, which was basically just like C++17 conventions that it appeared to not recognize. And I wasn't about to, like, I'm self-aware enough to know that my code is not like that perfect that an analyzer like that would detect absolutely nothing and my code is flawless. So I figured something had to be up, and sure enough, when I downloaded the full report that it generated, of course that's where like all the juicy goodness was, and yeah, there were some things in there that even flagged as like high severity and things that were like errors and stuff, but for whatever reason it still passed. Not sure why. But the other reason why I was unsure about it was I was literally playing around with it, trying to get it to fail. So one thing I did was I was like, okay, what if I basically I simulated hard coding a password into like the code base, and nothing happened. It still passed and succeeded. And I was like, okay, if this thing is actually worth its salt, it should have detected like, hey, it looks like you're hard coding credentials in here. That's a big no-no. Fail. But it didn't do that. So I was a little kind of iffy on that. So then I tried SonarQube, and SonarQube is kind of one of, I guess, like kind of the industry standards when it comes to, static application testing type stuff. So this was kind of a pain in the butt because I had to create my own server for it, which wasn't too terrible, but at the same time, it was more work than I wanted to do. And mind you, as we'll kind of get into later, I stayed up way too late one night trying to get all this implemented. So I tried SonarQube. After I got the server up and running, then I tried to integrate it into my pipeline, and that's where things started to fall apart for SonarQube because it took some trial and error to actually get it working. But then once I finally did get it working, unbeknownst to me, there was a proxy issue. So I spun up a Docker container essentially to run SonarQube in. So I used my proxy server to basically proxy a URL to the Docker container, so I wouldn't actually have to hard code the IP address and the port number. I could just put in like a URL. It'd be nice and easy. Apparently SonarQube didn't like that, and that gave me trouble for probably longer than it should have. And once I finally got that squared away, then I realized that SonarQube doesn't support C and C++ in its free community version, and I didn't feel like paying for it, so I basically wasted probably at least an hour, maybe an hour and a half, trying to go down this rabbit hole of SonarQube, which didn't end up working out for me. So then I decided to go back to SemGrep and see if I could make it work for me. And here is where I stayed up way too late trying to get this working, which the night that I was trying to get this working, I of course did not. Which honestly, that has to be one of the worst feelings in the world when you're working on something and you're trying to get it knocked out before you go to bed because you know if you can get it knocked out, it'll make you sleep a lot better. But then you just kind of get to this point of no return, and it's like, okay, if I don't go to bed now, I'm going to be straight up. I got maybe 3 hours of sleep that night. Like it was rough having to, which actually it wasn't all that bad, but I was definitely kind of noticing that I was not running on my usual, 7 to 8 hours of sleep. But yeah, it was not a good feeling going to bed that night because I was like, I did not get this working. It is not working. And if you know me and you've listened to the podcast for long enough, one thing that I cannot stand is leaving something undone. Like I am the type of guy that if my code doesn't work, I will not be satisfied until it is in a working state, which honestly, more often than, well, I don't know about more often than not, but there have been numerous occasions where I have spent hours and hours and hours trying to get something working when my better judgment told me to just get up, walk away, take a break. But the other side of me is like, I can't leave this undone. I gotta finish it. I gotta get it in a working state. But, it got to the point where it was, in the wee hours of the morning. And I was like, I just have to cut my losses here because there was a bunch of various different issues with SemGrep. So as we already touched on, it didn't cause the pipeline to fail when I wanted it to. So basically the point, at least in my opinion, of a static, application security testing tool is to basically scan your code for potential vulnerabilities, and if it finds them, basically alert you, and in the case of a CI/CD pipeline, basically kill it right then and there, because you don't want your code deploying into production with potentially known security vulnerabilities, right? Like if you have hard-coded credentials, whether that's passwords, API keys, secret keys, whatever, in your code base, you don't want that shipping to production. So I wanted to ensure that if there were any errors detected by SemGrep, that it would adequately and properly kill my pipeline. And this was way harder than I think it needed to be, because what I wanted it to do was I didn't just want it to kill the pipeline, I also wanted to see what the actual errors were. But on the flip side, it also printed out a bunch of, I guess, information / false positive messages that I didn't want to see and basically just clog up the output. So what I wanted was it to fail if anything failed, and if anything, and all the things that did fail, basically print those out so I can see exactly what the pain points were and what I need to fix. And yeah, like I said, I spent hours trying to get this to work, and it didn't. I did sort of get it to a point where it would fail and it would basically dump everything, and I was like, at this point, I'm going to be lucky to get 3 hours of sleep, so it's not where I want to be. It's not a win, but I am just going to take this because at this point, I was I won't say I was falling asleep, but it was definitely in that state where that you're not fully there. If you know what I mean, like you're kind of out of it. Like you're not like I said, you're not like literally falling asleep, like you can't keep your eyes open, but you know that like there's basically no energy left at this point. That's basically where I was at. So that was really annoying. But then the next day I did, spend another probably hour and a half or so trying to troubleshoot it, and did eventually get it working as I wanted to. Now, when it comes to the issues that the SAST tool was yelling at me for, some of them were actually decent, but others were kind of like, really? One of the good examples was it gave me an error, which it said, this is a, high severity vulnerability, and, the severity status was error. So basically like really, really bad. And what it happened to be was I was using sprintf, and I was copying data into a buffer, which honestly, that's a good catch. Very good catch, because that is a definition of a buffer overflow waiting to happen. You're using sprintf, which does no bounds checking whatsoever, and you're taking some other kind of variable length data and putting it into this buffer. Perfect example of a buffer overflow waiting to happen. The problem is, if you looked literally one line above the sprintf, you would see that I was allocating all of the memory necessary to account for the data that was going into the buffer. So in this particular case, I was basically allocating the data for the directory path, the name of the file itself, the .h extension, since this was in my my asset compiler to basically take things like images and fonts and basically convert them to .h files. So basically taking what the new name is going to be of the file, the destination where it's supposed to go, the .h ending, as well as the null terminator thing as well. So basically, I'm basically literally doing a calculation abovehand of how many bytes is this buffer, how many bytes does this buffer need to be? Okay, allocate all of that for this buffer, and then, do the sprintf. So, while yes, the tool was correct that this is a, buffer overflow waiting to happen, the problem is, the way I was calculating, the size of the buffer, I was using, the exact lengths of things of the variables coming in that I was using to put into the buffer. So suffice it to say, buffer overflow wouldn't happen because I was actually calculating and ensuring the buffer was big enough. It'd be no different than if I hard-coded the buffer size to say, 64 bytes and then did SN printf and then put, like 63 for like the size to have, one extra for the null terminator at the end. So basically that way you're basically saying only copy in up to 63 bytes into this buffer, and that's basically what I was doing. But of course the tool still yelled at me anyway. So that was just kind of one of the examples that I noticed like right off the bat of like, okay, really? But again, I guess it's good practice not to use unsafe, functions like that in C. There was, I think, some other issues where it was yelling at me too for like things like stir copy and things like that. But I didn't look super close into all of them, but from what I remember from the code base, I can say with at least like 95% confidence that almost, if not all of those instances, I'm doing bounds checking before I even call, the quote-unquote vulnerable functions to ensure that there is no buffer overflow that could happen. And there were some instances I know for a fact where I actually did test for buffer overflows specifically, and my code didn't allow them to happen because of the bounds checking I was doing. But yeah, so that was kind of way more explanation and talking than what we really needed to get into. But that's a pretty good segue into how we can use Homelabs for video game development, because literally that entire past, I don't know, how many minutes were we going for? Like 20, 25, maybe 30 minutes talking about, what I was doing with the nerdy things, basically is a one-to-one correlation to Homelabbing, right? Like, having a GitLab, CI/CD pipeline set up, which of course GitLab isn't the only, solution out there for CI/CD. There's other things like Jenkins and a few others as well that you can use. Also, I guess if you want to do this fully open source and do it like on GitHub, GitHub has their own version through GitHub Actions. So there's a bunch of different ways that you can do CI/CD, of course, but specifically in like a Homelabbing sense, you're probably going to be using something self-hostable, whether that's GitLab or maybe you're using some other Git server and using something like Jenkins, for instance. So there's a few different ways that you can do that, but when it comes to setting up your Homelab specifically for game development, one thing you do have to be cognizant of is your hardware resources that you require. So, of course, you're going to have some sort of development machine. Now, if we're being honest, you could absolutely have the biggest pile of junk laptop and compile a super complex, massive code base without issues if you have the right development environment set up. So, for instance, if you have a home lab with, maybe you have, a massive hypervisor, for instance, that has a bunch of cores available to it. So you create a virtual machine for your development environment, and maybe you allocate, 16 of the CPU cores available and like 32 gigs of RAM and tons of storage, so you're all good there. And you basically work exclusively out of that virtual machine. It doesn't matter at all what your laptop is, because you're almost certainly either going to be remote desktoping into that virtual machine or doing something through the command line, or maybe you're doing something like a VS Code or VS Codium or some other text editor that you can basically SSH into a remote server and kind of access the files that way, and basically use the editor on your local machine, but modifying files on a remote system. That's something you could absolutely do. And in cases like that, it wouldn't matter how piddly your local device that you're working on is, because the horsepower is on the server you're developing on. It's in that virtual machine. Now, of course, you don't have to do that solution. That's not the solution I do. Now, I do have multiple... I already touched on, I have multiple servers, both virtual and physical, in my home lab specifically for, build and dev environments. But more often than not, I do the development like locally on my own machine. Now, personally, since I got my M4 Pro Mac Mini, that has been like my absolute workhorse. So basically, anytime I've wanted to do code changes for the video game, I basically just work exclusively off that. But I do have development environments set up for some specific use cases, as we'll kind of get into in a little bit. But that is also an option you could consider too. But the main thing is, it honestly doesn't matter that much, like how many, like for instance, CPU resources you have. Especially if you're like compiling a game from source, like if you're using something like a compiled language, or even if you're using something else. The compilation aspect, it's basically a matter of how much patience do you have and how long do you want to wait in between builds and how big your code base is. Because obviously, if you have a very small code base, you could honestly get away with one core and your builds are going to be pretty quick. But if you have a really big code base with tons and tons of files and a more complex build system, yeah, it's going to be beneficial if you have a lot more cores to kind of do some of that compilation in parallel. And the other thing that also you have to keep in mind too is, depending on, what kind of, in this case, video game that you're making, what kind of graphics capabilities do you need to have? Because one thing that you have to be mindful of, especially if you're using virtual machines and you want to test the game on virtual machines, is depending on what you're doing for graphics, you might run into issues trying to test your game in a virtual machine, because sometimes they'll complain about the the graphics capabilities not being there. For instance, if you're doing so, I guess I have two examples for you. One of them is the Windows virtual machine that I have for my dev environment. So of course, Windows, it has a GUI, it has the graphical interface and everything. But for a while, I had no ability to actually run the game aside from like the command line utility to like test stuff. Like I couldn't actually like launch the game itself to get into any of the GUI testing at all. Because it was a virtual machine and it didn't have like the OpenGL drivers associated for it, so it wasn't able to launch it. So that is one thing you have to keep in mind. Now, there is a workaround in order to get that working, but that is something you have to be mindful of. The other example is one of my Linux dev environments. It's command line only. There is no graphical user interface, which is a problem when I want to do one of the embedded builds, because the embedded builds that basically takes, either the image assets or the font assets and converts them into a header file, it has to open up an OpenGL context. That's basically how Raylib does it. It opens up an OpenGL context in order to basically convert them. And because obviously there is no graphics interface, there is no GUI, there is no graphics drivers, none of that. Obviously there's no OpenGL, so that ran into some massive issues. So there is a workaround for that too. Actually, in my CI/CD pipeline, I literally have all the code specifically for that, because my GitLab runners are obviously headless as well, meaning there's no graphics there for them, and they of course have to do these builds. So that's kind of how I have to get around it. So that is something you do have to keep in mind. But the other thing too, when it comes to graphics, is if you're, not making a basic, 2D sprite type game, and you're doing something a lot more demanding, with a bunch of 3D graphics and rendering and all that kind of stuff, you also have to be mindful about what kind of GPU horsepower you have. Because if you're making, say, kind of a more, AAA game probably isn't the right word, because if you're just a solo dev, you're probably not making a AAA game. But let's just say you are doing something with a lot of graphics intensive, whether that's, 3D models or you're using like a bunch of effects and that kind of a thing that takes a lot of GPU resources. You want to make sure you have adequate hardware to test that for a couple of reasons. One, you want to know what the minimum specs are going to be, because if you're trying to run this just on like your integrated CPU and it's running like dog water, you're not necessarily sure if that's just because the integrated CPU on your laptop isn't strong enough, or your graphics is just really not optimized. So that's one thing. The other thing too, like I said, is you kind of want to know what the minimum specs are, because if you're able to run this no problem, say you're like a baller and you got like the latest NVIDIA, what are they up to, like 50 series I think GPUs, so say you have like a 5080 or something and everything runs smooth as butter, that's great. but also having, other environments with less powerful GPUs to try to see how it runs on those as well, to kind of gauge and tweak some of the graphics settings and kind of that regard. So that's also another thing you have to keep in mind too. And then also, if you're doing anything with sound, this isn't necessarily as big of a deal these days since sound cards aren't really a thing. But I guess if you're trying to support, older operating systems, that is a little bit more of a concern. Also, I guess another thing that we should also mention too is if you want controller support, having a way to adequately test, the use of controllers. What kinds of controllers are you going to support? Now, this is mainly assuming that you're going to be building for like a PC or a desktop type game. If you're doing some kind of development specifically for, some kind of actual console, whether that's, a Game Boy Advanced or like PlayStation or whatever, you're probably going to want to have at least some sort of emulator that you can, run your game in the emulator. And in order to do that, you of course need to make sure that your system is able to run the emulator, for one thing, and two, is able to run it well enough that you can actually, get kind of the performance that you're expecting. So those are some of the things that you kind of want to be mindful of when thinking about kind of like the hardware requirements that go into your kind of your home lab setup for video game development. So then once you kind of have the hardware sorted out, then you kind of move into the software side of things. So of course, when it comes to software, there's a couple key things that you kind of have to decide on first. One, of course, probably the most obvious, is you have to figure out what language you're going to be writing your game in. Personally, for me, the language I'm using is C++, but you can use other languages. You can use Java, you can use Python, you could use C if you want, you could basically any language you want, you could write a game in it. There's also things too, like, are you going to be using a game engine? Are you going to be writing everything from scratch? Are you using a graphics library? Those are some kind of questions you have to kind of be asking yourself. And then, of course, what do you want your development tools to be? And this is definitely going to depend on what language you go with. For instance, depending on what language you choose, that is slightly going to dictate what kind of development tools you're going to use. So, like, for instance, if you're going to use, say, like a language like Java, you're probably more inclined to maybe use an editor like maybe Eclipse or something that has really good built-in Java support compared to maybe like the native Xcode if you're on a Mac, or maybe, VS Code. Now, granted, VS Code, it has basically plugins for basically every language out there, at least most of them. So you definitely could do that too. But at least in my experience, there are like kind of certain languages that if I want to work in a certain language, I kind of want to use a specific editor. Of course, my default tends to be VS Codium. It's just at least for me, a pretty good all-around editor. But if I want like specific support for like a specific language, I'll generally kind of tend towards a specific IDE. Like, for instance, if I'm on like my Mac Mini and doing game development for my video game, typically I'm using Xcode for it. Just because Xcode has, at least in my experience, pretty good built-in support for C++. It has pretty good auto-completion and things like that for what I want to do. And it has a really easy, seamless way to like integrate the build system into it, so I can just kind of like hit the play button and it'll build it for me, which I guess saves me a couple keystrokes from typing make in the terminal. So that's, of course, one thing you have to keep in mind as well, what kind of development tools you're going to use. Also, if you're using something like C++, you probably want to look at some kind of memory analyzer, something like Valgrind, for instance, basically to check to make sure that you're not leaking memory or having any kind of memory errors, which, in fairness, if you're using a language that is memory safe, like, say, like a Python or a Java like we talked about, Valgrind probably isn't necessarily that important for you to have in your tool suite. And then, of course, the next one is version control. You have to have some idea of what you're going to be doing for your version control system. Personally, I use Git. Git is kind of like the dominant one in the industry nowadays. If you want to use some other version control system, I guess knock yourself out. But personally, for me, I use Git. But that is something that I guess you technically do have to decide on your own, like what you want to do for that. So then it kind of comes to kind of marrying the two together. So like we said, first you have to figure out your hardware. You have to figure out, what kind of hardware components and what level of how overkill do you need to go with your hardware setup in order to do builds and do testing and things like that. And then, of course, figuring out what your software stack's going to be. And installing any tools that you need, right? Like, so if, for instance, if you're setting up a multiple build environments, maybe you're setting up a hypervisor, whether that's Proxmox, ESXi, Hyper-V, whatever the case is. You're setting up your hypervisor with multiple virtual machines for various testing environments. Maybe that's something you're doing. From the software side, maybe you're having to install various packages, whether that's your development tools or whether that's the languages themselves, or if you're using a game engine, the game engine, things like that. And then if you're doing any kind of networking, like multiplayer support, having some kind of environment inside your home lab, maybe some of those virtual machines that you spun up in order to kind of create that multiplayer scenario in order to adequately test that. And then whatever you're doing for version control, maybe you spin up another virtual machine to kind of host your Git repository so you can kind of keep your changes there so you can work between multiple systems. Or for instance, if you want to build across multiple systems, it's kind of nice to have that one single source of truth that you can then just clone from. And then, of course, if you're working off your local machine, having that as well. So my setup specifically, I think this would be kind of a good exercise to kind of walk us through it. We kind of already touched on some of it in the Nerdy Things segment, but to kind of highlight and recap things. So for version control and CI/CD, I use GitLab. So I have local copies of the Git repo on various machines all across my home lab, from my various laptops. Of course, my M4 Pro Mac Mini have different, local clones of the repo. And then, of course, the GitLab server has, is the main remote repo for now. When I do inevitably, I guess, release this, I do plan to make it completely open source and probably put it on my GitHub, which will kind of be a pain because I'll have to completely rework the automation suite for GitHub Actions, which I'm not necessarily looking forward to. But I guess we'll cross that bridge when we get there. But when it comes to the GitLab CI/CD pipeline, I think we'll probably kind of gloss over most of this because we kind of touched on a decent amount of it in the Nerdy Things segment. But there's 4 main phases of my build pipeline right now. I'm sure that'll grow and expand as the game kind of matures and it actually kind of gets to a point where I could, in theory, deploy it, or maybe deploy a server or something for a multiplayer aspect. We're still far from that, but for right now, there's four main jobs in the, well, not really jobs, 4 main stages in the pipeline. So there's the build phase, the test stage, and then there's the stages for building documentation and deploying the documentation. So the first stage is the build phase, which the build phase basically is just a sanity check to make sure the code actually compiles. Can you build the test program, and can you build the actual release executable? If you can do that, you move on to the test phase. Now, the test phase, or I guess test stage, has a few different components to it. There's the actual test cases themselves. So as part of the build phase, it builds the automated test suite as well as building the actual release version of the game for the specific platform it was built on. So like I said in the Nerdy Things segment, there's now 2 GitLab runners that do this. One is a Linux x86 architecture, and the other is a Linux ARM architecture. So during the build phase, a release build will be built for Linux x86 and Linux ARM64, and then it'll also build the test builds for those as well. So during the test stage, each of those automated test suites will be run basically just as a sanity check to make sure all the test case pass and there's no memory leaks involved. Assuming those pass, then it goes on to the static analysis testing that we touched on that I was implementing. So that is basically just kind of a sanity check to make sure I didn't do anything dumb as far as a blatant, hey, this is probably a vulnerability, you probably want to change it type of a deal. So assuming all those pass and it passed all the testing phases, then we get into the documentation aspect of it. So the first part of the building the documentation is strictly that. It goes through and uses Doxygen to basically compile all of the, go through, parse all the Doxygen documentation throughout the code base, and basically generate the various HTML files and even the PDF for the documentation. Then the second part of the build documentation phase is it basically puts all that documentation into a nice Docker container, specifically an Nginx container, which is just a simple web server, and it packages all that up into a container and then pushes it to the container registry within GitLab. And then the fourth stage is the deployment stage, which will then basically take that newly published container from the container registry and upload it to my Docker server that I have running in my home lab. So that way I can basically go to the internal URL I have for my documentation, and then right there I'll have a nice web interface where I can navigate through all the documentation, see all the classes, see all the functions, and kind of like go down if I'm interested to know what a function does specifically, and I don't want to do like the jump to definition type thing. I can just go to that site, click the documentation, find the function I'm looking for, and I can view it all right there. And also, there's a downloadable PDF version as well that I could download locally. Like for instance, if I was doing some traveling or something, and like I was on an airplane or for whatever reason couldn't remote back into my home lab to access the documentation, I could always have a local copy in PDF form. So those are the main stages of the CI/CD pipeline. But since my GitLab instance is self-hosted, there's of course runners involved. Now, we kind of touched on this a little bit in the Nerdy Things segment, but to kind of summarize briefly, in order for GitLab to kick off CI/CD pipeline jobs, it has to have what are known as GitLab runners. So basically how the runners work is they work through basically like an API sequence. So basically they kind of work with the GitLab host themselves. So the GitLab host will kind of notify the runners and assign them tasks and stuff for them to work on. So in a nutshell, how it works is you register a GitLab runner with GitLab itself, and then GitLab knows if there's any kind of like pipeline jobs or whatever, and then based on what runners are available, GitLab can then assign those jobs to the various runners. So for instance, I have both Linux, x86, and ARM versions, like I said. So one thing that you can do with GitLab CI is you can specify, tags for runners. So you can say like, hey, I want to only do this portion of the build on, say, an x86 Linux GitLab runner, and the GitLab will then basically identify a runner that is x86 Linux and basically push the job to that one, and so on. So that's kind of how it works there with the GitLab runners. And then of course I have the build, test, and dev environment. So in addition to having runners that perform all the builds and tests when I push code changes, I also have dedicated environments set up specifically to allow me to build and test my code for Linux, macOS, and Windows across the different platforms, x86 and ARM, so a total of 6. And this way, if I experience any sort of build issues on any platform, I can basically go directly to that dev environment and test and make sure it works there, and basically have for the most part, a suite of dev tools in those dev environments that I can kind of, make any code changes that I need to in order to get things working. And also kind of in this process, like in these dev environments, like specifically for the Linux one, I have tools specifically, for developing on that platform. Now, as you are probably well aware, if you've listened to the podcast for long enough, one of my probably favorite tools that I've come across during my game dev journey has been Valgrind. And I've only ever been able to get it to work on Linux. So in all of my Linux dev and dev environments, both on, like laptops and like in virtual machines and whatnot, I have Valgrind installed, and I regularly check to make sure that there are no memory errors or memory leaks. Now, the keen-eared among you might notice that I did touch on in the CI/CD, stages portion, but doesn't your automated test suite test for memory leaks? And that doesn't use Valgrind, and you are correct. But that automated test suite to check for memory leaks is very dumb. And what I mean very dumb is it's basically just a wrapper around the new and delete functions for C++ and all the various malloc, realloc, calloc things in C. So essentially what it'll do is it basically hijacks the, say, malloc function or the new function. And whenever that function is called, it basically takes it accounts for like the line number and how much memory was allocated, and basically stores that and the pointer associated with it, and stores that in a map. And then basically what it does is once the program's done running, if there's anything left in the map, there's obviously a memory leak. And so it's very dumb in that regard. Now, it gets the job done in the sense that like it's a nice kind of basic check to kind of check yourself to make sure you're not leaking memory. But it doesn't do memory errors. So Valgrind's really good at this in the sense that if you have any memory errors, it will let you know. So, and the key difference here is you can run Valgrind, have no memory leaks, but it'll still yell at you. Whereas my automated test suite, you could have memory errors and it won't yell at you. And what I mean by a memory error is one of the classic examples is, say you have a for loop that goes one index too far in your array. Probably more often than, well, I won't say more often than not, but there's a decent chance if you kind of go like an extra one too far, your program's probably not going to crash. Like, you're not guaranteed to crash, since we're talking about C and C++ that don't do any sort of bounds checking like this. It's not memory safe. But if the program doesn't crash, and you don't leak any memory, who's to say that you didn't have any issues? But Valgrind will absolutely catch that, and it will let you know. And of course, you don't want to have any instances like this of any kind of memory errors, because the existence of memory errors is kind of like the static analysis, testing. It's basically just kind of a sanity check. Like, yeah, this potential line of code doesn't necessarily mean you're going to get pwned by X vulnerability, but it's probably for the best that you fix it, so you kind of remove the chance of it happening. Kind of things like that. So Valgrind has definitely been one of the go-tos in my dev environment for basically making sure that my code is, one, not leaking any memory, and two, not having any sort of memory errors. So when it comes to dev environments, since I mentioned that I have 6, which I guess technically more than that if you count like personal development machines, like I didn't in the dev environments, my Mac Mini and like Linux laptop and other things like that aren't included. But the reason why I have so many is, well, actually I probably have too many, but my general rule of thumb is this: you should have as many dev environments, specifically dev platforms, as platforms you want to support. And I realized when I said that made absolutely no sense. So what I mean is, if you want to support x86, Windows, and Linux, you should have dev environments for x86 Windows and x86 Linux to basically test to make sure that your code works in both of those environments. If you don't plan to support ARM, then you don't necessarily need an ARM dev environment. If you do plan to support ARM, then yeah, you should probably have an ARM dev environment for whatever platforms you want to support. So because in my case, I want to support ARM and x86 for Windows, macOS, and Linux. So that means I have to have 6 dev environments to basically make sure I got all my bases covered. And the reason why I recommend this is for a couple reasons. Well, the primary reason is so you can replicate issues, because especially if you're using a compiled language, you're not guaranteed that just because it compiles on one system, it's going to compile on a different system. Or just because it compiles on one architecture, it's going to compile on a different architecture. So ensuring that your code can compile across all those architectures is key. But the other thing too is compiled languages sometimes they don't operate necessarily as you expect. So compiling is one thing, but sometimes you can get undefined behavior on one operating system, whereas on a different operating system, it works just fine. So this is why you want to have those different, dev environments to basically make sure that it actually works as expected across all the platforms you plan to support. And the other reason why it's important is inevitably, if you do end up releasing your game and someone comes to you with an issue saying, hey, I'm trying to run your game on, say, I don't know, Windows for ARM, and it's not working and I'm getting this error. If you don't have a Windows on ARM system, first, I'm not exactly sure how you got it built for ARM, although I guess maybe they could have built it themselves, or maybe have like a GitHub action that does it by itself. Regardless, they somehow have it building for Windows on ARM, but if you don't have a Windows on ARM development environment, you can't really adequately troubleshoot their issue, because there is a chance that the Windows x86 Windows won't encounter that issue, but Windows on ARM does encounter that issue. So that's another reason why it's so important to have dev environments for every platform and every architecture you plan to support, so you can troubleshoot these kinds of issues. So again, I think kind of like the main takeaways here when it comes to kind of having a home lab set up for your game development is, first, you have to have, probably the biggest thing is dev environments, because I've touched on them so much. But the other thing too, some kind of Git solution or whatever your source control solution is, having that somewhere. And then also, hopefully you're doing some sort of automation, I would hope. Some kind of CI/CD pipeline will make your life a lot easier. So having that somewhere in your home lab is also something that you can look into as well. And then as far as again, the hardware components, we kind of touched on this. You want to make sure that the hardware you're selecting for your various dev environments is adequate enough to, one, build the game itself, and also run it too. You don't want to be testing your game and it running at 2 FPS and being like, yeah, it's probably fine. The server I'm running on just isn't that powerful, so I'm sure it's probably fine. Because like I said, when we were talking about the hardware aspect, you want to make sure your hardware is good enough so you can kind of check to see if your issues with, say, graphics performance is a hardware issue, like your just GPU isn't powerful enough or your CPU isn't powerful enough, or is it an optimization issue that you just kind of need to rework some things? So those are some of the kind of big things that it comes down to. And of course, identifying, your kind of the basic stuff. We already touched on the hardware. What's your software stack going to be? What language are you using? Are you using a game engine? What kind of dev tools do you need to have installed? Things like that. So we have gone way too long. I spent way too long indulging myself in my nerdy things segment. In fairness, it has literally been 3 months since I talked about stuff on my video game. So I think you can at least give me that I haven't bored you, or maybe you weren't bored, but I haven't indulged in that in over 3 months, so I think going a little long talking about it was justified, at least in my opinion. But again, this is my podcast, so that's really all that matters. So let's wrap up with the trivia question for the week. So Apple announced Apple CarPlay in June of 2013 at WWDC and is available on all iPhone 5 and later models running iOS 7.1 or later. In September 2014, the first car with a full version of CarPlay was released. What was the car? So what was the car that was released in 2014 that was the first car to have a full version of CarPlay? And again, you get points for if you can give me the manufacturer as well as the model of car. If you said the Ferrari FF, congratulations, you got this week's trivia question correct. And yeah, I know the Ferrari FF, it's not exactly Ferrari's best looking car, but then again, not every car can be an F40 or an F430 Scuderia. But then again, at least it's not a PT Cruiser. which I also understand that as a very, very, very low bar, and I probably insulted every single Italian out there that I even uttered the name Ferrari and PT Cruiser in the same sentence and had any sort of comparison. So for that, I guess I apologize to all the Italians out there. But yeah, Ferrari FF, when you think first cars with CarPlay, at least for me, before I, kind of looked up the answer for this trivia question, I would definitely not have gone with Ferrari for the answer. I probably would have gone with, maybe BMW, maybe Mercedes, some more economical brand, like maybe like a Toyota, a Honda, or a Ford or something like that. But no, Ferrari. So who knew? More you learn. So if you got this week's trivia question, definitely props to you for that. And if you enjoyed this episode, definitely be sure to leave it a rating and review and subscribe if you haven't done so already to the Dark Assassins podcast. And also be sure to share with a friend or family member. And if you have any questions, comments, topics, or ideas for future episodes or anything about this episode, if you're on YouTube, you can leave a comment down below, or you can always shoot me an email at contact@darkassassinsinc.com. There's a link for that down in the show notes below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.